Jupiter is not just another planet in the solar system. It is the heavyweight giant that dominates everything around it. Fifth from the Sun, Jupiter is so massive that it contains nearly 2.5 times the mass of all the other planets combined. If Earth is our familiar rocky home, Jupiter is something entirely different, a vast, swirling world made mostly of hydrogen and helium, more like a small unfinished star than a solid planet. In the night sky, it has been noticed since prehistoric times, shining as one of the brightest natural objects visible from Earth, usually outshone only by the Moon and Venus. Ancient observers did not know its true scale, but they understood its importance. The Romans named it after Jupiter, their chief deity, a fitting name for the largest planet orbiting the Sun. The scale of Jupiter is difficult to picture because it stretches the limits of everyday comparison. Its diameter is about 11 times wider than Earth's, meaning more than 1,000 Earths could fit inside its volume if space were used efficiently. Yet Jupiter is still only about 1/10 the diameter of the Sun, reminding us that even the largest planet is tiny compared with a star. Jupiter orbits at an average distance of 5.20 astronomical units from the Sun, or about 778.5 million kilometers. From there, it takes nearly 11.86 Earth years to complete one orbit. A single Jovian year is almost 12 years on Earth, but its day is astonishingly short. Jupiter spins once in about 10 hours, faster than any other planet in the solar system. Jupiter's rapid rotation has a visible effect on its shape. It is not a perfect sphere. Instead, it is an oblate spheroid, slightly squashed at the poles and bulging around the equator. The radius at its equator is about 7% larger than the radius at its poles. This happens because the planet's fast spin pushes material outward near the middle, much like water flinging outward from a spinning bucket. On a rocky planet, solid ground resists that distortion, but Jupiter has no solid surface in the way Earth does. Its visible face is a deep atmosphere, layered over denser and stranger material below. The result is a planet whose very shape reveals the power of rotation, gravity, and fluid motion working on an immense scale. Unlike Earth, Mars, or Venus, Jupiter is a gas giant. Its atmosphere is made mostly of hydrogen and helium, the two simplest and most abundant elements in the universe. By mass, Jupiter's atmosphere is roughly 76% hydrogen and 24% helium, with small traces of carbon, oxygen, sulfur, neon, ammonia, water vapor, phosphine, hydrogen sulfide, and hydrocarbons. These minor ingredients may sound insignificant, but they help create the colors, clouds, and chemistry visible from space. Jupiter's composition is similar to the Sun's in broad terms, though Jupiter never became massive enough to ignite nuclear fusion. It is sometimes casually called a failed star, but that phrase can mislead. Jupiter is a planet, formed in a disk around the young Sun, not a star that almost succeeded. The surface we see when we look at Jupiter is actually the top of its atmosphere. It is divided into bright zones and darker belts that wrap around the planet in latitudinal bands. These bands are shaped by powerful winds moving in opposite directions, creating turbulence where they meet. Jupiter's clouds are not calm sheets of vapor, they are part of a planet-wide weather system driven by rotation, internal heat, and chemistry. The bright and dark stripes change over time, sometimes fading, intensifying, or shifting in color. Beneath the visible cloud tops, pressure and temperature rise dramatically, and gases gradually behave more like fluids. There is no clear solid surface where a spacecraft could land. Instead, descending into Jupiter would mean entering deeper and deeper layers of crushing pressure. The most famous feature in Jupiter's atmosphere is the Great Red Spot, a storm so large that Earth could fit inside it, depending on its changing size. This enormous oval has been recorded since 1831, and similar observations may go back even earlier. It is not simply a red cloud, but a gigantic high-pressure storm system rotating in Jupiter's atmosphere. Its reddish color may come from complex chemistry caused by sunlight interacting with compounds in the upper clouds, though the exact explanation is still studied. What makes the Great Red Spot remarkable is its endurance. On Earth, even the strongest hurricanes last days or weeks. Jupiter's Great Red Spot has persisted for generations, surviving in an atmosphere with no continents or oceans to disrupt its circulation. Jupiter also gives off more heat than it receives from the Sun. This does not mean it shines like a star, but it does mean the planet is internally active. The most likely source is ongoing contraction. Jupiter's immense gravity slowly compresses its interior, converting gravitational energy into heat. This internal heat helps drive atmospheric motion and may contribute to the planet's extreme weather. Deep inside Jupiter, the pressure becomes so intense that hydrogen behaves in unusual ways. Scientists believe the planet contains a mantle of fluid metallic hydrogen, a state where hydrogen conducts electricity like a metal. Below that may be a diffuse inner core of denser material. Jupiter's interior is not a simple layered ball, but a complex transition from gas to fluid to exotic high-pressure matter. One of Jupiter's most powerful invisible features is its magnetic field. Generated by electrical currents within the fluid metallic hydrogen deep inside the planet, Jupiter's magnetic field is the strongest of any planet in the solar system. Its magnetosphere, the region controlled by this field, is enormous. It interacts with the solar wind, the stream of charged particles flowing outward from the Sun, and stretches far into space. If Jupiter's magnetosphere were visible from Earth, it would appear larger than the full moon in the sky. This magnetic environment traps charged particles and creates intense radiation belts. For spacecraft, that makes Jupiter both scientifically valuable and dangerous. Electronics must be protected carefully, especially when missions pass near the planet or through regions influenced by its moons. Jupiter's influence extends beyond its atmosphere because it has an entire system of moons. At least 115 moons are known to orbit the planet, turning Jupiter into something like a miniature solar system. The four largest are Io, Europa, Ganymede, and Callisto, often called the Galilean moons because Galileo Galilei observed them in 1610. They are bright enough to be seen with common binoculars, appearing as tiny points of light lined up near Jupiter. Their discovery was historically important because it showed that not everything in the heavens orbited Earth. These moons are not all alike. Each is a world with its own geology, composition, and scientific mysteries, shaped by gravity, radiation, and tidal forces from the giant planet they circle. Among Jupiter's moons, Ganymede stands out because it is the largest moon in the solar system, even bigger than the planet Mercury. Europa attracts intense interest because beneath its icy surface may lie a global ocean, making it one of the most intriguing places to search for conditions that could support life. Io is the most volcanically active body known, its interior constantly flexed and heated by gravitational interactions with Jupiter and neighboring moons. Callisto, more heavily cratered and ancient-looking, preserves clues about the early solar system. Together, these four moons show how Jupiter is not just a planet but a gravitational engine. Its pole shapes worlds, heats interiors, drives activity, and preserves environments that are dramatically different from anything found on Earth. Jupiter also has rings, though they are far fainter than Saturn's. Instead of bright icy bands, Jupiter's rings are made mainly of dust. They include an inner halo of particles, a relatively brighter main ring, and a more distant gossamer ring. In visible and near-infrared light, the rings appear reddish. Their dust likely comes from small moons struck by impacts, which kick material into orbit around the planet. Because the particles are tiny and easily disturbed by radiation, magnetic effects, and sunlight, Jupiter's rings are delicate and constantly changing compared with Saturn's broad icy system. Their exact age is uncertain. They may have roots stretching back to Jupiter's formation, or they may be continually refreshed by impacts over time. Jupiter may have been the first planet to form around the young Sun, and that early arrival mattered. As the solar system developed, Jupiter's gravity influenced the movement of gas, dust, asteroids, and growing planets. Its migration during the primordial era likely affected how the inner planets formed and how material was distributed. Today, Jupiter remains a major gravitational force, shaping asteroid populations and affecting the orbits of smaller bodies. Since 1973, robotic spacecraft have visited Jupiter through flybys and dedicated orbital missions, revealing details impossible to see from Earth alone. More missions are on the way, continuing the exploration of its moons, magnetic field, atmosphere, and origins. Jupiter is not only the largest planet nearby, it is a key to understanding how planetary systems form, including those around other stars. If you found this helpful, please like this video and subscribe for more explainers.